In this problem, we're given the following function and asked to sketch the magnitude characteristic of the Bode plot, labeling all critical slopes and points. And if we look, we've got a constant, we've got a simple zero. Okay, so we have a simple zero, meg equal 1 radian per second. We have a simple pole at the origin, and then we have a set of quadratic poles. So let's go through and look at the magnitude characteristics of each of those terms individually, and then we'll add them all up to get the characteristic of the function shown. So our constant, you notice we have a 0.2, so magnitude characteristic for that constant is 20 log base 10 of 2. That's minus 13.98 dB. And you can see that's a constant for all frequencies. Now for our simple zero, its magnitude characteristic is this. Okay. So at omega equal 1, the gain is 0 until it gets to omega equal 1, then it goes up at 20 dB per decade. Then our simple pole at the origin, here's the characteristic for it. It basically has a slope of minus 20 dB per decade. So at omega equal 1, it has a gain of 0. Now the quadratic poles, a little more difficult. If we go in and look, the quadratic poles has a characteristic that looks something like this. You can see the calculations there for tau and zeta. There's the quadratic poles. It has a gain of 0 because it gets out here. Then it has this slight peak. The slope over here is minus 40 dB per decade. So that's the characteristic that it has. Now we can calculate this peak value here. We know it occurs, the peak occurs at omega equal 12. So if we go into our function and say, okay, what value does this have at omega equal 12? So if we go in and plug in and say, okay, at omega equal 12, what value do I have? So if we plug in 12, we have j12 over 12 squared, so that's j squared is minus 1. We have j12 over 36 plus 1. So at omega equal 12, we have j 1/3. Well, this is 1 over j 1/3, so minus j3. The magnitude of minus j3 is 3. So at omega equal 12, this function has a magnitude of 20 log base 10 of 3, or 9.54 dB. So notice what we did is we went in and said, okay, at omega equal 12, what's the magnitude? Okay, so this peak value here is 9.54 dB. So now let's go in now and sketch the characteristics. So what we start off with, here's our plot. So we go in there and look. We had a gain, okay, minus 13.8 dB. And then we also have that simple pole at the origin. So it breaks down at 20 dB per decade. So this is because of the simple pole at the origin. And because of the gain at omega equal 1, this has a gain of minus 13.98 because of that constant. Okay. So it has a value of 0 back over here at 0.2. See, so it has a value of 0 back over at 0.2. Now at 1, the simple 0, its gain starts increasing at 20 dB per decade. This is going down at 20. Okay. So when that 0 turns on, our slope goes to 0. Now when we get out here to 12, we have a characteristic that looks something kind of like this. This slope is minus 40 dB per decade. And if you remember, our quadratic pole had a gain of 9.54. This point here is minus 4.44 dB at omega equal 12.